Today we're going to talk about how to solve two-step equations. There are some steps to solving linear equations. There's 5 steps. You use these 5 steps to solve any type of linear equation. Step 1 would be to use the distributive property to remove any grouping symbols. All that means is if you see that there's parentheses in the equation, you need to evaluate those and remove them before you do anything else. Step 2 would be to simplify the expression on each side of the equation. All that means is to combine like terms. So if you have one side of the equation with two numbers that are like terms, you need to combine those together. Step 3 is to use properties of equality to collect the variable terms on one side of the equation and the constant terms on the other side of the equation. All that means is you want to isolate the variables on one side and isolate all the numbers on the other side. Step 4 means to use the properties of equality to solve for the variable. That's just doing a one-step equation at the very end. You want to use the properties of equality to isolate the variable completely and figure out its value. And then step 5 is simply to check your solution. You always need to check your solution anytime you solve a linear equation. You know if you're right or wrong because if you plug that number that you get for the variable back into the equation and the answer is true, then you know that you found the correct solution for the equation. Some things you need to know about solving equations that are 2 steps or more is typically you use the inverse operations in reverse order of the order of operations. So as you've grown up, you've learned that something called PEMDAS. You've learned that you need to start with parentheses, then evaluate exponents, do multiplication, division, addition, and subtraction in that order. When you go to actually solve an equation though, what you do is you use the inverse operations, but you do the order of operations backwards. Let's look at the example that we have here. X divided by 2 plus 5 equals 11. The operations being performed on x is being divided by 2, and then we're adding 5 to x, which equals 11. 11 and x divided by 2 plus 5, they're the same. This equal sign is saying that this side and this side are equal. However, if we want to solve this equation, the operations we're going to perform to isolate the x, we're going to do the inverse operations. Notice it says add 5 here. Right here we say subtract 5. Divide by 2, we're going to multiply by 2. So we're going to do the inverse operations, and then we're also going to do them in reverse order. Look, we got divide by 2, add 5. Well, now we're going to subtract, to actually solve for x and isolate, we're going to subtract by 5 and then multiply by 2. So if I go to solve this equation, I subtract 5 from each side, which will give us x over 2 equals 6, and then I multiply by 2 on each side, and our answer is going to be x equal, because the 2's cancel, so we just have x left, x equals 12. And that's how we do the inverse operations in a reverse order of the order of operations. That's how you're going to solve about any linear equation. Let's look at this example, 4x minus 10 equal 22. So again, with PEMDAS, you would think you'd mess with this first because multiplication and division come before addition and subtraction. But remember, we do things in reverse operations when we solve equations. So we're going to start here with the subtraction sign, and we want to use the inverse operation, which is the addition. So we're going to add 10 to each side. When we've added 10 to each side, that gives us 4x equal 32. Now because we have a multiplication here, 4 times x, we want to use division, the inverse operation. That's going to give us x equal 8. Now we just want to check our solution here. Plug this back into the equation. You got 4 times 8 minus 10 equal 22. Well, 4 times 8 we know is 32 minus 10 equal 22. And 32 minus 10 is 22. And we know that 22 does equal 22, so x equal 8 is the solution to the equation. Now let's look at this example. 9 plus 2x equal 23. Again, we want to stay away and let's not mess with the multiplication first. We want to go in reverse order. Let's deal with this addition, or this positive number 9. We want to subtract 9 from both sides, which will give us 2x equal 23 minus 9 is 14. And now we want to deal with the multiplication. 2 times x. Inverse operation is division. So we get x equal 7. Plug that back into the problem. 9 plus 2 times 7 equal 23. Well, we know 9 plus 2 times 7, that's 9 plus 14 equals 23. And 14 and 9 is 23. And 23 and 23 are equal. So that means x equal 7 is the solution. Now we're going to look at 2/3 x minus 4 equal 4. We got a fraction in here. Don't let the fraction scare you. Not even going to mess with it at first anyways. We're going to do reverse order, so remember we start with the addition and subtractions. So we got a subtraction here, inverse is addition. We're going to add 4 to each side. Going to add 4 to each side. When we do that, we end up with 2/3 x equal 8. And now we can solve this side by, all we got to do, this is a multiplication here, but it's 2 divided by 3. See the division sign? So we're going to multiply by the reciprocal here. If we multiply 2/3 by its inverse, which is 3 over 2, we know inverse operations cancel out, so that means the 2's cancel and the 3's cancel. So we get x equals 8 times 2/3. 3 halves. 8 over 1. 8 times 3 is 24. 2 times 1 is 2. So we have x equal 24 over 2. We know that that is going to equal 12. Let's plug that back into the equation. So we have 2/3 times 12 minus 4 equal 4. Well, 2/3 times 12, put 12 over 1. This is a fraction, got to make it a fraction. 2 times 12 is 24. 3 times 1 is 3. 24 over 3, we know that's 8. 8 minus 4 is 4. Oh, 4 equal 4. That's a true statement. We know that x equal 12 is the solution to this equation. Now let's look at this problem here. Again, we have a fraction. Well, we're not going to deal with it first. We're always going to deal with this addition or subtraction sign here. But this is a positive 8 because there is no sign in front of it, which indicates that this would be positive. Don't mistake this negative sign for thinking this is a negative number. The sign that's in front of the number lets you know whether it's negative or positive. So this is a positive 8. We're going to subtract 8 on each side. When we subtract 8 on each side, we're left with negative x over 5 equal 4. Now you see I brought the negative down because we never did anything with it. Alright, it comes down with the number that it's in front of. Now if we want to get rid of this 5, we got division, inverse operations, multiplication. Now we always want to multiply, so we're going to multiply by 5, but we're not just going to multiply by 5. We want to get rid of the negative sign too. We're going to multiply by negative 5. That will cancel. We know negative negative is a positive. And we're left with an x. Don't forget to do it on this side. 4 times negative 5 is negative 20. That should be our answer. Let's go up and check it. 8 minus negative 20 over 5 equals 12. Negative 20 divided by 5 is negative 4, so we have 8 minus negative 4 equals 12. Negative, negative, when you multiply those, it's positive, so it's 8 plus 4 is 12, and 8 plus 4 is 12. 12 equal 12. We know that this right here is our solution. Last problem. We had 11x minus 7 plus 4x equal 23. Notice we have the same terms we have like terms on this side. We have 11x's here and 4x's here. This one's positive. This one's also positive. We can combine like terms. All right, and the reason we can do that is the commutative property of addition and subtraction say that we can move these around any way we want. 11x, negative 7, plus 4x. These can all be moved around however we want. We can reorder them. So what we're going to do is we're going to just take the 11x that's positive and add it to the 4x that's also positive. And that means there's total on this side 15x's. Then we got this minus 7 equal 23. So that's combining like terms. Now we can just go ahead. Let's get rid of this negative 7. Get rid of the additions and subtractions. The inverse operations obviously positive 7. So we have 15x equal, it's 30. Last step, 15 times x, inverse operations division. Divide by 15. And that's x equal 2. Let's check and see if that's the correct answer. We got 11 times 2 minus 7 plus 4 times 2 equal 23. Well, 11 times 2 we know is 22 minus 7 plus 8 equal 23. 22 minus 7 is 15 plus 8 equal 23. 15 plus 8 is 23. Lo and behold, 23 equal 23. That is true. That means x equal 2 is the solution.